very nice to meet everyone in person. So my name is Boon, and I am a staff Android engineer at Threads. Yeah, so today I'm going to talk about demystifying baseline profiles. Yeah, so my tagline is this is, I'll just edit and it works, right? So apparently we can talk about it. Yeah, so for the agenda today, we are trying to focus on the consumption side of things. So for profile installer, we want to learn what it does and why do we need to add it. And then macro benchmarks, how does it come into the picture? And the whole validation journey itself. So from installing an APK on a test device and what to expect and look out for. And finally, what to expect for various distribution methods like Google Play or other app stores, etc. Yeah. So what we are not focusing on today is going into details on how to get it set up and generation itself. Yeah. So yeah, let's get started. So yeah, baseline profiles. So if you haven't seen this talk before, this is a good introduction for baseline profiles. Yeah, so the whole concept of baseline profiles is to kind of like provide a optimized path for your app and send it to the Android runtime for it to compile ahead of time so that you could get good speed for your app itself. So you have app improvements with that. So if you would like to find out more about baseline profiles on how to make it work or some of the workings, you could refer to this talk. It's New York City's DroidCon last year, yeah, by Rahul, yeah. So there's also this talk by Christina, where she talks about reflection on a year of Compose. So why is baseline profiles talked about? Like, why do I talk about this presentation? Is that commonly baseline profiles is associated with performance on Compose UI itself. So yeah, you could read up on some of the pain points on Compose UI, and how does baseline profile come into the picture itself. Yeah, so if you have time, give it a watch. Yeah, so this statement is very common with developers right now, which is, I installed my app and baseline profile doesn't seem to have an impact. So you could ask around, and that seems to be pretty much the experience. Like everyone did something, but doesn't seem to have an impact. Or maybe you have some impact, but it's non-deterministic, right? So we want to look into these specific issues, and let's discuss about some of the problems that everyone faces. Yeah. So, profile installer. Let's talk about it. Okay, so up on my screen here, we have something, a wall text. You may have seen it before, you may have not seen it before. So this is the actual baseline profile. So on a consumption journey itself, you start with something like this, and then you add it into Android Studio, and it will package it into your application itself. Yeah. So if you follow Google's guidelines, you will reach this point. At some point, it will tell you to add this dependency into your builds. So it says add the profile installer library, right? It kind of tells you that it enables local baseline profile compilation when the cloud profiles aren't available. Yeah, but that's really what it says. If you try to dig to any form of documentations, it doesn't say much. So what does it actually do? So profile installer, what is it? So first and foremost, profile installer is a catch-all fallback mechanism for installing baseline profiles. So it is the mechanism to kind of catch everything when you have several fall-through scenarios. So some of these scenarios are like Google Play. So if Google Play, when it doesn't have a cloud profile, it fallbacks to baseline profiles. So there are also scenarios like cloud profiles are only supported from certain API versions and above. So if your device can't support cloud profiles, it will fall back to baseline profiles with the profile installer. And then finally, we have side loading. So side loading is kind of a wide term, but I'll just call it app side loading. So this is common, like using, just downloading an APK and installing it in your app. That's side loading. Yeah. So for that kind of scenarios, profile installer will also be default back mechanism. Yeah. So what does it do? Profile installer has many responsibilities, but in general, there are 3 core responsibilities. There are some others, but we will only cover these 3 today. Yeah. So the first one is that it tries to read a source material, and then it tries to transcode it, and then writes the profile into the disk itself. So that's its key role, writing baseline profiles. Okay. So the second is that it registers an initializer to write profiles during startup. So we'll get into the specifics later, but yeah. And finally, it provides a broadcast receiver to perform actions through intents. So let's dive into it. So read, transcode, and write. Okay, so if you dive into the code of profile installer, you will notice that everything points into this static function called write profiles. So it's basically the bread and butter, the core function that it calls every time. So if we dive deeper into the source code itself, just to see what's going on, we can see that most of these responsibilities are dedicated into this piece of code called, this class called device profile writer. And it pretty much performs everything here. So what it basically does is that this profile writer will first read the source. So as you can see here, so these are the assets that are packaged into your APK itself. So it points to there, and then it reads the file, right? So the next steps, what it does is that it does a transcoding. So what is the transcoding about? So if you look into the source code itself, so you will look at kind of like things like that. So let's put our focus into some of the versions. So what you see here is basically API versions. So if you see like SV2, Tiramisu, these are your API like 21, 22, etc., right? So if you notice that this piece of code returns a profile version, right? So there is this v015_s, yeah. So what it means is that, so this piece of code behaves differently when it comes to different API levels, and different profile version exists, yeah. So this piece of code, what does it do? It tries to find out which API version you're on, and then it will convert or transcode the profile according to the version that it is matching. Okay, so back to the source code. So the final step is to write the actual profile itself, and yeah, you're done. That's kind of what it does. Cool. So let's move on and talk about writing a profile at app startup. So, this is the piece of code. Anyone here is familiar with the Android, what do you call that? Android startup libraries? Yeah. So if you're familiar with it. So profile installer basically kind of use that framework to run all, to register what it needs to do in the startup code itself. So it has this initializer, and then that's where all the ceremony is performed. So we'll dive into it. So in the initializer code itself, this is basically what it calls immediately. Yeah. So we want to just look into just specific stuff. Every other thing is not really important at this point. So let's look into the main function. So it calls delay after first frame, and yeah, that's what it does, delay after first frame. So in delay after first frame, we can see that the code itself calls the choreographer's frame callback. So what it does is that it posts a callback after the first frame when your app launches, and then it calls to another function called after delay. So this is the function. So let's look into it. So in install after delay, we can see that there's some more logic again, but those are not important. We want to focus on this function called write in background. If you notice, it's just cascading things. It just delegates further down and eventually reach this part. So in background function, you see that there is a thread pool executor, and basically eventually runs the code write profile. So what it does here is that it writes the profile in the background thread. And that's it. There it is. Yeah. So the next thing we want to cover is the broadcast receiver. So if you're familiar with broadcast receiver, Profile Installer has its own broadcast receiver as well. So it has actions like this. So we'll focus on action install profile. It has action skip file and more. So yeah, what does it do? So this is just a snippet of the entire class, but you could see that if your intent is passed in and it matches whatever intent is, whatever actions that it matches, it will just call a function. So in this case, action install profile, it calls write profile immediately. There's more, but we'll just focus on this. So to sum up, Profile Installer ensures baseline profile is written at startup, and it offers some synchronous actions through a broadcast receiver. So that's kind of like high level of what it does. Next, we'll move on to macro benchmarks. So if you try to implement baseline profiles, eventually you will reach this screen. It says automate measurement with the macro benchmark library. So it's a lot of text, so let's not look at it. Yeah, macro benchmarks. So what is it? To kind of summarize it, it's a tool that allows you to measure things during runtime through a JUnit test runner. So in our particular use case, baseline profiles is what we're interested in. Macro benchmark offers a compilation mode API for testing various time. Android runtime is basically kind of like the main component that decides how it optimizes things. And then through this API, you could configure it to several modes and then decide how do you want to test or measure your code with it. We'll see how it's important later. Okay, macro benchmarks. What does it do? So it does two main things. The first thing that it does is that it prepares your app to the correct state for testing. So that's really important, and we'll get to that later on. The second thing it does is it measures timings and provide you with data for reference. So you have before and after or several scope. It gives you some data for you to reference. So next, we'll move on to preparing your app. So this is a startup benchmark. It kind of looks like this. So we'll focus on this particular test case where we say, we want it to have a compilation mode of partial, and it requires baseline profiles. So inside the API itself, there are some configurations that you can do for this particular API. So you could configure it as require baseline profiles. You can choose to not include it. Yeah, there's some configurations that you can do. But for this talk, we'll focus on require baseline profiles. So inside the implementation of this compilation mode API, under the hood, this is really what it does. So the first line, it broadcasts a profile install to your receiver that you added in your profile installer. Source code, right? Sorry, dependency, yeah. So once it sends this broadcast and profile installer receive it, what happens is that it triggers a profile write immediately because it's a false write, and it only completes after its success. is successful, when you have a result. So the next step, right after installing a profile, the macro benchmark queues the process to your app itself. So it will stop the app. And then the next line, it call this specific function that we will dive into it. So you can see that this is command package compile, and we'll like to focus on this specific line of command. Yeah. So this basically translates into this command. So what it is, this is an ADB command, and it does something called package compile. And so what happens when you run this command over ADB? It basically forces the compilation of the app to speed profile mode. So this is quite important, and we'll talk about it more later. Yeah. So to summarize, macro benchmark installs your app. Compilation mode API force writes baseline profile through an intent broadcast. And then finally, it performs ahead of time compilation through ADB. So this entire process is quite important. Let's talk more. We'll focus right now on how we do dog fooding. Everything will come together pretty quickly, so let's get into it. So this is a typical Android Studio. I don't know how everyone tests app, but for me, it's pretty straightforward. There's a play button. I click it, and then my app runs, right? So you typically test in release mode or something like that. You know, when you're dog fooding, you need to test whether things works for you, if there's any crashes and stuff like that. This is actually pretty common practice. So this is one approach. Another approach that I believe is pretty common is that you just send an APK to someone. So an APK here, you click on it, you install, app install, right? Yeah. So is there anybody that use other kind of testing methods? Anyone have something to share? Yeah. Mm-hmm. Mm-hmm. Yeah, so through ADB, right? Yeah, so that's also another method, yeah. So these are all pretty everyday methods. We'll slowly cover why this is important. So remember we talked about profile installer, and then we talked about macro benchmarks. How we do dog fooding is basically we install an app, we launch it, we navigate to the place that we want to test, and then we do a test, right? So notice something odd here. Macro benchmark basically did some preparation work, right? So remember, it does two things, right? It installs the profile, and then it compiles things ahead of time. For our testing flow, we have not done any preparation work. We just install the APK, and then we navigate to the part where we wanted to test. So this is significant. So now we want to talk about app preparation for dog fooding tests. So the first and foremost, this is really important. If you wanted to check if baseline profile is effective or not, you need to run this command called package dex-op. Yeah. So we'll see what it does. So this long command kind of dumps the state of the Android runtime targeting your app. So you might get something like this. So this piece of string data, yeah, we want to focus on this thing called status verify. Okay, we want to focus specifically on the status itself. So anything other than speed profile is bad for dog fooding. What does that mean? This means that your app is not ahead of time compiled. So if you are using baseline profiles and you're testing this, with your workflow using your dog fooding process, if it's not speed profile, things are not working as intended. So what can we do about it, right? So in that case, we can try to do what macro benchmark does, so which is to ensure baseline profile is written. So there's a few approaches. One of them is to just run the app. Remember, profile installers registers a initializer and it writes the profile during runtime, right? So if you run the app itself, it will write the profile. So what kind of breadcrumbs could we look for to figure out if the installation has been done? You could just check for the tag profile installer, and then if you see something like this, that signals the end of the write itself. So this is step one. You want to ensure that profile is written. Alternatively, you could just, remember we have a broadcast receiver that does the action install profile. You could send that intent through ADB as well. It will basically trigger a synchronous write for your application. So now once that is done, we want to move on to compiling the app ahead of time. So remember, macro benchmark this command under the hood, right? So what we can do here is to run this command. And when everything works, it will say success. Yeah, so if things go success, everything is good, you can test. And then there's always a but. So one thing that is really, it's a big problem, which is that package compile can actually fail, and that due to many various reasons, and it's really flaky. Yeah, so let's talk about it. You may see this error depending on your dogfooding device and your test. Yeah, technically just your test device itself. Yeah, so if you see this, it could mean that the hardware manufacturer itself disabled ADB to ensure you can't do commands like this, or there are some other optimizations that is preventing you from sending an ADB command. If that's the case, if you met this exact same error message, you notice the word compile is spelled wrongly. Yeah, this is actually distinctive. If you could identify this specific error message, you could try something. You could try turning off battery optimizations. Once you turn off battery optimizations, there's no guarantees, but I have instances where this kind of worked. So yeah, your mileage might vary here. Okay, so despite the failures, if you eventually gotten a success case, right, the next best thing that you have to do is to ensure that the compilation of state of the app itself. So what you need to do is to repeat the check app compilation state step. Yep, so remember the kind of like DexOp thing that you have to query that returns you this? Yeah, so you run it, and if you eventually get this, this is the good case. It is now returning a speed profile, and that's specifically what we wanted. Yeah. So if you have this, we could say that the entire process is successful, and you can test. You can navigate to the place that you want to test. So it's good to go for dogfooding. Yeah. So this is for dogfooding. Now we'll move on to something else. What to expect for Google Play Store distribution. So for Google Play Store, yeah, there are a few things that we want to go through. Yeah. So what to expect? So a few things. Profile installer will write the baseline profile during startup, as we discussed before. The Android runtime will compile the app during idling phases through a background job, and that usually happens overnight. Yeah, so this is for like normal installation, but we will cover the case of Cloud Profile in the next slide. So Cloud Profiles, what to expect? So these cases is only valid for devices that supports Cloud Profiles. This is typically several API versions only. Yeah. So when you meet these, when the Google Play Store has Cloud Profile for your apps, Google Play Store will sideload the profile onto your device itself. And this is with immediate effect. What that means is that there's no delays, there's no ceremonies that you need to do, and it works as intended. In that case, profile installer will skip writing profiles and not do anything. Cool. So what about other distribution channels? So for other distribution channels, it will behave exactly the same thing with Google Play distribution without cloud profiles. So it's the repeat of the slide again, which is profile installer will write the profile during startup. Android runtime will compile the app during idling through a background jobs, and it happens overnight as well. Yeah, so with that in mind, yeah, you could kind of figure out how behaviors will be and how will this entire situation affects your app testing itself. Yeah, that's actually all I have for today. So if you have questions, I'd love to kind of talk about it. And yeah, thank you.